Well, hello, hello. Well, welcome to my classroom, as empty as it could be. And there it is. Kind of looking a little deserted. Love to have my kids back. But we're here today to perform some science experiments. And today's experiment is called Wagons Hoe. And in Wagons Hoe, we're going to see what happens to motion when we add mass, which would fall under Newton's second law. So you can see we're going to measure it in centimeters. Over here we're going to be using some steel marbles. And here's our question. What happens when we add mass? There's 0 weights, 1 weight, 3 weights. We're going to do 3 trials on each, so that'll be 9 rolls total. Then we'll average them using a calculator. That's just the easiest way to do it, I think. And we're going to measure a couple ways. This is our ramp. You can see our ramp, we're using one of our dictionaries. It's hard to get the kids to use real dictionaries anymore. They tend to like it on their computers. Okay, and I can see I've set my ramp up so it's right on the edge of this tile, because I know these tiles are each 30 centimeters. So I can measure by how many tiles, and then I can use my tape measure to measure how many over for the tiles, so I can get a fairly accurate measurement. Today I'm going to be using my cart, which is a Lego cart that I built just for this. As you can see, this is all like Lego Technics pieces. And the keys on here, I have some space to fit some weights. But if you happen to have like a Lego Friends car that's an convertible, you could easily add some weights to that and do the same thing. Or if you have any kind on there, it could be a Batman vehicle, you name it, as long as it doesn't have a turning mechanism. And you can see I'm making sure the wheels spin well, because if they don't, well, that adds friction. And from our last experiment on friction, you probably realized what happens when you greater friction equals a little less motion. Okay, so, and here's my steel marbles. And when I add those, I'm going to put them in to these nice little spots that I made. But if you had, like, for example, you had a Lego truck that you had, or a favorite thing you wanted to make, and you just happen to have a nice little quartz crystal like this, which has quite a bit of mass, I could throw it on my scales and figure out exactly. But at least I can tell how much it would be without any extra mass and with extra mass, and see how that affects it. So I'm going to start off today, the first one on here, and of course I'm going to keep track of it. I'm going to set my cart at the very top of the ramp. Now I'm not going to push, because that would be a whole different type of experiment. I'm just going to let it roll. Well, that didn't go very far. That's right. So I'm going to measure it from the bottom of the ramp. And let's see, here we go. See, the bottom of the ramp looks to me like 15 centimeters. So our first one will be 15 centimeters. I make sure I keep track of everything so I can do this. So I'm going to put 15 cm. Now I'm going to do it again just to see if it does any better. And rolls again. Whoa, hey, I think it might have gone a little farther. Now, you never know why. It's a little hard sometimes to figure that out, but who knows? Maybe you'll become a good physicist that can. And this one looks to me like it's about 16 centimeters. All right, so 16 centimeters on that one. Let's go ahead and do our third one. And let's see where we end up with that one. And that looks like 16 centimeters as well. Okay, so that's pretty easy to do, because now I can come over here and I'm going to put 16 centimeters and 16 centimeters. Now I could do the average in my head on that one, but all I'm going to do is I'm going to add those 3 up. So that would be 47. 15 plus 15 plus 15 is 45, plus 46 is 47. So that's the total. Now I'm going to need to divide it by 3. So I'm going to come into my classroom and I'm going to go swoop on one of my calculators. But, oh, there's Darth. Okay. All right. So we know we have Here, we'll clear it. Everything on there, clear. 47 divided by, we had 3 trials, so divided by 3 equals. And that's 15.67. So that would be 15 2/3 centimeters. But it's close enough that I'm going to go ahead and I'm going to round it to the nearest centimeter. It'll be a whole lot easier when I go to graph. But, so that would be 16. Okay, so there's our average right there. That one's done. Let's go ahead and add a weight and see if that changes anything. Okay, so we got a marble. I'm going to put this in here. I'm going to put it in the center, only because I always like to keep things as balanced as I can. And there we go. Why, that didn't seem to do much. Okay, let's go ahead and look. Let's look. Well, it went, looks like 14. So 14 centimeters for that one. I'll put that right over here. Okay, gonna do it again. I'll put the card up on top. And we're just gonna let it go. Again, it didn't go too far. Looks like it kind of went about the same distance it did last time. And lo and behold, there we are, 14 centimeters. Notice I measure it to the same spot every time because that's a control. That's a control. We want to make sure we have all our controls in place if we want to make our experiment be valid. Okay, I'm going to do it one more time. Okay, and that looks like it might have gone another centimeter or so farther. No, it is exactly 14. 14 centimeters again. Well, that's going to be kind of an easy for an average. So 14 centimeters. And one last time. Wait, I already did it twice. What am I kidding? 14 centimeters. And our average is 14 centimeters. Now, when I have 3 on there, do you think it's going to go farther or not as far as? Well, according to the way that one's worked out, I know I would be thinking, hey man, it's not going to go very far. So let me bring it over here. Bring the card over here. Add on our extra weights. Okay, there they are. All gleaming. Well, not so gleaming. There's a little bit of rust on those things. Not made someplace that has very high quality standards maybe for these. Or maybe they just didn't care whether they were bright and shiny or not. Okay, and we let it go. Ooh. Well, let's see where this one went. Why, that one went, it looks like 12 and a half. So let's do that one, 12.5. So we can use a decimal in here for sure. The other ones were just kind of more exacting. Do it a second time. Okay, and this one went 13. Okay, all right, so 13 it is. And one final try here. And this will be the last roll we need to do for Wagons Ho. Okay, and there we go. And what did we get on this one? Looks like 13 and a half. Okay, so 13.5 centimeters. Well, using this in my head right there, I see that this one is a half of a centimeter short of 13. This is 13, and this is half a centimeter above. So I'm going to take that half centimeter there, add it to this one. I know my average is going to be 13 centimeters. Now that is odd. So that's what Wagons Ho did. Did it come out the way you expected? Did you think it was going to go farther? Well, you kind of have to think about this. We know that when we have forces,